A list comprehension is a syntactic construct available in some programming languages for creating a list based on existing lists. It follows the form of the mathematical set builder notation as distinct from the use of map and filter functions. Overview: consider the following example in set builder notation. This can be read, is the set of all numbers 2 times, where is an item in the set of natural numbers, for which squared is greater than. The smallest natural number, x equals 1, fails to satisfy the condition x2 greater than 3, so 2 or 1 is not included in S. The next natural number, 2, does satisfy the condition as does every other natural number. Thus S consists of 2 or 2, 2 or 3, 2 or 4. So S equals 4, 6, 8, 10. Yea, all even numbers greater than 2. In this annotated version of the example, is the variable representing members of an input set. Represents the input set, which in this example is the set of natural numbers, is a predicate expression acting as a filter on members of the input set. Is an outputs expression producing members of the new set from members of the input set that satisfy the predicate expression. Braces indicate that the result is a set, the vertical bar and the comma are separators. A list comprehension has the same syntactic components to represent generation of a list in order from an input list or iterator, a variable representing members of an input list. An input list. An optional predicate expression. And an outputs expression producing members of the output list from members of the inputs iterable that satisfy the predicate. The order of generation of members of the output list is based on the order of items in the input. In Haskell's list comprehension syntax, the set builder construct would be written similarly, as here, the list, 0 represents, x2 greater than 3 represents the predicate, and 2x represents the output expression. List comprehensions give results in a defined order. And list comprehensions may generate the members of a list in order, rather than produce the entirety of a list, thus allowing, for example, the previous Haskell definition of the members of an infinite list. History: the SETL programming language had a set formation construct, and the computer algebra system Axiom has a similar construct that processes streams, but the first use of the term comprehension for such constructs was in Rod Burstall and John Darlington's description of their functional programming language NPL from 1977. Smalltalk block context messages which constitute list comprehensions have been in that language since at least Smalltalk 80. Burstall and Darlington's work with NPL influenced many functional programming languages during the 1980s, but not all included list comprehensions. An exception was the influential pure lazy functional programming language Miranda, which was released in 1985. The subsequently developed standard pure lazy functional language Haskell includes many of Miranda's features, including list comprehensions. Comprehensions were proposed as a query notation for databases and were implemented in the Clijley database query language. Examples in different programming languages. The following provides a few examples of specific syntax used in programming languages. Although the original example denotes an infinite list, few languages can express that, so in some of those cases we show how to take a subset of rather than a subset of. Equals b prolog equals. A list of the form, t, e1 and d1. N and dn, local vars, goal is interpreted as a list comprehension and calls to it equals /to and constraints. A list comprehension is translated into a for each construct with an accumulator. Equals C equals. C lazily generates results on demand. Results can be automatically processed in parallel on a multi-core system using parallel LINQ. Equals slon equals. For if x2 equals clojure equals. Clojure generates infinite lazy sequences. Use take to get the first n results from the infinite sequence. An example without the infinite sequence. Equals CoffeeScript equals. CoffeeScript brings list comprehensions to JavaScript. Equals Common Lisp equals. List comprehensions can be expressed with the loop macros collect keyword. Conditionals are expressed with if, as follows. An infinite lazy sequence can be created in a variety of ways, such as the CLOS object system or a yield macro. Elixir equals. The same example in Elixir. Elang equals. The same example in Elang. F equals. The F generator comprehension has the list comprehension syntax elements. Generator comprehensions can be used to generate lists, sequences and arrays. Generators are of the form, for x in collection do. Yield expr for lists and sec for x in collection do. Yield expr for sequences. For example, Falcon equals. The comp generic method family provides wide support for comprehension. For example, the mfcomp method can be applied to an array. Falcon can also use functional generators to provide input lists. For example, the following code uses a continuation to create a set of pairs. Method comp was introduced in version 0.9.6, and methods macomp and mfcomp in version 0.9.6.2. Groovy equals. Groovy supports list comprehension style expressions for any kind of Java collection including lists, sets, and maps. The int variable is shorthand for the implicit parameter to a closure. The above is equivalent to Haskell equals. Please refer to the main example in the overview. Here, the list 0 generates natural numbers one by one which get bound to variable x. X2 greater than 3 represents the predicate that either accepts or rejects a given variable's value, and 2x represents the result expression. There might be several generators and test predicates in one list comprehension expression in Haskell, in effect defining nested loops, for example. The above expression becomes unproductive at some point, when new excess keep being generated only to be rejected later on. This is so because any test can only reject a value it is given, not any future ones. This can be dealt with using bounded list generators always or by enclosing a generator inside a take or take while call, limiting the number of generated values. Hakes equals. Hakes 3 released with array and map comprehension. However, Hakes 2's syntax required use of lambda. JavaScript 1.7 equals. JavaScript 1.7 has array comprehensions. The SpiderMonkey JavaScript engine of the popular Firefox browser from Mozilla Foundation supports them. For example, the sequence of integers can be obtained by prototyping the number object or introducing a range function. Julia equals. Julia supports comprehensions using the syntax and multidimensional comprehensions like Mathematica equals. The cases command with a rule delayed in the second argument provides a list comprehension mechanism. Alternatively, OCaml equals. With batteries, OCaml batteries included as uniform comprehension syntax for lists, arrays, enumerations, lazy lists, sets, hashtables, etc. Comprehension are of the form expression x3 equals Python equals. The Python programming language has a corresponding syntax for expressing list comprehensions. The Python equivalent of the above example is racket equals. Racket provides functional versions of for loops, which are essentially list comprehension syntax. The imperative for can also be used, combined with Racket's generator library to produce an infinite generator. Ruby equals. In the Ruby language you can use multiple ways to simulate this function, for example. Or you can define your own method. Scala equals. Using a for expression. Using a collections. Scheme equals. Although there is no standard list comprehension syntax in a 5rs, many implementations provide an extension for this. For example, in Chicken Scheme. There is also a portable library srfi/42 eager comprehensions, which in particular includes list comprehensions. setl equals. Smalltalk equals. Super Collider equals. In Super Collider list comprehensions are implemented as routines, whose results can be collected with a message or A shortcut syntax is provided for defining list comprehensions, which internally translates to a routine. Visual prologue equals. Similar constructs. Monad comprehension equals. In Haskell, a monad comprehension is a generalization of the list comprehension to other monads in functional programming. Set comprehension equals. Version 3x and 2.7 of the Python language introduces syntax for set comprehensions. Similar in form to list comprehensions, set comprehensions generate Python sets instead of lists. Set comprehensions generate racket sets instead of lists. Dictionary comprehension equals. Version 3x and 2.7 of the Python language introduced a new syntax for dictionary comprehensions, similar in form to list comprehensions but which generate Python dicts instead of lists. Hash table comprehensions generate hash tables. Parallel list comprehension equals. The Glasgow Haskell compiler has an extension called parallel list comprehension that permits multiple independent branches of qualifiers within the list comprehension syntax. Whereas qualifiers separated by commas are dependent, qualifier branches separated by pipes are evaluated in parallel. Comprehension standard library contains parallel and nested versions of its comprehensions, distinguished by for versus for in the name. For example, the vector comprehensions for vector, and for /vector create vectors by parallel versus nested iteration over sequences. The following is racket code for the Haskell list comprehension examples. In Python we could do as follows. XQUERY and XPATH equals, like the original NPL use, these are fundamentally database access languages. This makes the comprehension concept more important, because it is computationally infeasible to retrieve the entire list and operate on it. In XPATH, the expression is conceptually evaluated as a series of steps, where each step produces a list and the next step applies a filter function to each element in the previous step's output. In XQUERY, full XPATH is available, but FLWOR statements are also used, which is a more powerful comprehension construct. Here the XPATH book is evaluated to create a sequence. The where clause is a functional filter, the order by sorts the result, and the XML snippet is actually an anonymous function that builds transforms XML for each element in the sequence using the map approach found in other functional languages. So, in another functional language the above FLWOR statement may be implemented like this. LINQ and C equals. C 3.0 has a group of related features called LINQ, which defines a set of query operators for manipulating object enumerations. It also offers an alternative comprehension syntax, reminiscent of SQL. LINQ provides a capability over typical list comprehension implementations. When the root object of the comprehension implements the iterable interface, rather than just executing the chained methods of the comprehension, the entire sequence of commands are converted into an abstract syntax tree object, which is passed to the iterable object to interpret and execute. This allows, amongst other things, for the iterable to rewrite an incompatible or inefficient comprehension, translate the AST into another query language for execution. C++ equals, C++ does not have any language features directly supporting list comprehensions, but operator overloading has been used successfully to provide expressive syntax for embedded query DSLs. Alternatively, list comprehensions can be constructed using the arrays remove idiom to select elements in a container and the STL algorithm for each to transform them. There is some effort in providing C++ with list comprehension constructs syntax similar to the set builder notation. In Boost Range, 1, library there is a notion of adapters, 2, that can be applied to any range and do filtering, transformation etc. With this library, the original Haskell example would look like. Full example is here, http://y4bpglju. This implementation uses a macro and overloads the for x path /separator. Interestingly, XPath separator that skips intermediate nodes in the tree is implemented in LEESA using what's known as strategic programming. In the example below, catalog, book, author, and name are instances of catalog, book, author, and name classes, respectively. See also, the select statement together with its from and where clauses in SQL, programming language, mathematical notation, monads and functional programming for monads and monadic notation in general, for other programming language constructs used to process sequences, generator, map. For other programming language constructs copied from the mathematical notation, guard, pattern matching, operator. Notes and references. List comprehension in the free online dictionary of computing, editor Dennis Howe. Trinder, Phil. Comprehensions, a query notation for DBPLs. Proceedings of the Third International Workshop on Database Programming Languages, Bulk Types in Persistent Data, NAFPLIAN, Greece pages 55–68. Wadler, Philip. Comprehending Monads. Proceedings of the 1990 ACM Conference on Lisp and Functional Programming, Nice. Wong, Lim Soon. The Functional Guts of the Kleijley Query System. Proceedings of the 5th ACM SIGPLAN International Conference on Functional Programming. International Conference on Functional Programming pages 1–10. Haskell the Haskell 98 Report, Chapter 3.11 List Comprehensions. The Glorious Glasgow Haskell Compilation System User's Guide, Chapter 7.3.4 Parallel List Comprehensions. The Hugs 98 User's Guide, Chapter 5.1.2 Parallel List Comprehensions. OCaml OCaml batteries included, language extensions introduced in OCaml batteries included. Python Python Reference Manual, Chapter 5.2.4 List Displays. Python Enhancement Proposal PEP 202, List Comprehensions. Python Reference Manual, Chapter 5.2.5 Generator Expressions. Python Enhancement Proposal PEP 289, Generator Expressions. Common Lisp Implementation of a Lisp comprehension macro by Guy Lapham. Clojure Clojure API documentation, for macro. Axiom stream examples. External links, SQL-like set operations with list comprehension one-liners in the Python cookbook, discussion on list comprehensions in Scheme and related constructs, list comprehensions across languages.